Hi friends, welcome to this presentation. Today I am going to describe some important questions and answers on periodic properties. The first question, which of the following species has the highest electronegativity? There are four answers are given: carbon sp2 hybridized, nitrogen sp hybridized, carbon sp3 hybridized, nitrogen sp2 hybridized. Actually, the electronegativity is in direct relationship with the effective nuclear charge. It increases when effective nuclear charge increases. In the case of hybridized orbital, the percentage of S character influences the electronegativity value. For sp hybridized orbital, the S character is 50%, which is highest among others sp2 and sp3 hybridized orbitals. And nitrogen is more electronegative than carbon. So, the correct answer is B, N-sp hybridized. The second question, which is the incorrect statement among the following? The first option is successive ionization energies always increase for an element. Second, electronegativity does not depend on effective nuclear charge. Third one is electropositive character increases as ionization energy decreases. The fourth one is as electronegativity increases, metallic character decreases. The first statement, successive ionization energies always increase for an element, is a correct statement, but actually we have to select the incorrect statement. The first statement is correct because you see the successive electrons, because the removal of successive electrons increases the effective nuclear charge that give rise to more bound electrons which are difficult to remove. So if we remove the first electron, then the second electron become more bound due to higher effective nuclear charge. So the first statement is a correct statement. But in the second statement, electronegativity does not depend on effective nuclear charge. Actually, this is an incorrect statement because actually the electronegativity and nuclear charge is directly dependent on each other. So that's why the second statement is an incorrect statement. So the correct option is second one. And the third and the fourth, all are the electropositive character increases as ionization energy decreases. That is the correct statement. As electronegativity increases, metallic character decreases. That is also a correct statement. So the correct answer is B. The next is a third question. The correct order of ionization potential for the given elements is, there are four options are given. Actually, now you see the first element we have to select. For A, it's a carbon. For B, the first element is a sodium. For C, there is the first element is oxygen. The fourth one is nitrogen. But actually, the nitrogen is oxygen and nitrogen both are more electronegative species, and you see the nitrogen has half-filled electronic configuration. As it is a stable configuration, the removal of electron is difficult. So the ionization potential is higher for nitrogen than that of oxygen. And for carbon and sodium, sodium is electropositive and has lower ionization potential than carbon. So the fourth one is the correct answer because nitrogen, then oxygen, then carbon and sodium. So sodium is having least ionization potential and nitrogen is having highest ionization potential among these four elements given. So the fourth option is a correct option. The next question, which of the following groups has the lowest electron affinity? Halogens, alkali metals, alkaline earth metals, none of these. So out of four options given, which is having the lowest electron affinity? Actually, the electron affinity increases from left to right as effective nuclear charge increases, except for inert gases. So halogens are having higher electron affinity. But in the case of alkaline earth metals, they have completely filled s orbital, that is a ns2 electronic configuration, whereas alkali metals have half-filled s orbital, that is 1s1 or ns1 orbital electronic configurations. So it has more affinity towards electron to become a stable, fully filled electronic configuration. So from this observation, the alkaline earth metals are having lowest electron affinity. So the answer third answer is a correct answer. Then the next question is a set of quantum numbers of outermost subcell of valence shell for two elements A and B is given as follows. For A, n is equal to 4, L is equal to 1, and for B, n is equal to 5, L is equal to 2. Then which statement is incorrect? The first statement, atomic number of A is smaller than B. First statement is correct because A is having smaller principal quantum numbers. The second statement, element B has filled d orbital. The second statement, as L is equal to 2, it seems there is a presence of d orbital, and it has to be a possibility to be a filled orbital. So the second statement is also a correct statement. The third statement is seem to be incorrect because both A and B will not have same atomic size. Because due to different atomic numbers, so the both A and B have same atomic size as the option is given, but actually they are different atomic size. That's why the option C is the correct answer. Then question 6. Which of the following elements has the lowest electron negativity? So actually it is obvious that the potassium is electropositive and placed in the left hand side of the periodic table. So out of this potassium, carbon, iodine and aluminium, the potassium is a correct answer for this question. The next question, for an element X, the ionization energies in kilojoule per mole are reported as follows. The first ionization energy is 500, second one is 4560, third ionization energy is 6910, fourth one is 9540, and fifth one is 13400. Which element is X? Actually now we observe the ionization energies values are given. First, second, third, fourth and fifth. The difference between the first ionization energy and the second ionization energy is highest among the other successive differences. So here you see the sodium is only possibility that sodium is having one electron in the valence shell, and after the removal of this electron it becomes stable configuration. So a big jump is observed for sodium for the second ionization potential. So all other elements are having more than one electrons in the valence shell. The big jump is not observed for first successive removal of electrons. So the correct option is sodium. That's a C is the correct options. The question number 8. Which element has lowest ionization energy? Lithium, potassium, fluorine and oxygen. Actually the potassium has lowest ionization energy due to a larger atomic size than lithium. The attraction between valence electron and nucleus is less, therefore the removal of electron is easy. So the option B is a correct option because other things like fluorine and oxygen, they are placed in the right hand side of periodic table, so they are actually more electronegative and effective nuclear charges are more, so they have a higher ionization energy. So between lithium and potassium we have to select one. There is a potassium is the correct option. Then question number 9. Which atom has the smallest atomic radius? Lithium, sodium, fluorine, nitrogen. Actually the atomic radius decreases from left to right in a periodic table and effective nuclear charge increases. So fluorine is present in the right side of the table, so fluorine is the smallest and answer C is the correct answer. Then the question number 10, the effective nuclear charge of helium and boron atoms are 4 answers are given, 2.10 and 3.90, 1.70 and 4.70, then 1.00 and 3.50. The fourth one is 1.70 and 4.70. So actually the correct option is B, 1.70 and 4.70. How we arrive at the answer we have to see now. Actually for helium atom 1s2 is the electronic configuration. The screening constant for 1s1 electron there is a 1 into 0.30 is for 1 electron, there is a screening constant. So for 1 electron is a 1 into 0.30 0.30. Then effective nuclear charge Z minus S is equal to 2 minus 0.30 is equal to 1.70. For boron atom, as a configuration is 1s2, 2s2, 2p1, has no contribution from electrons present in 2s2p. Then the screening constant is for 1 electron of boron atom, 1 into 0.30 is equal to 0.30. Then effective nuclear charge is equal to Z minus S, that is equal to 5 minus 0.30 is equal to 4.70. So the 1.70 and 4.70 is the correct option for the effective nuclear charge of helium and boron. So the option B is a correct option. The 11th question, which is the biggest anion among the following: chloride, anion, fluoride, hydride and bromide ions. So among these four anions are given, which is the biggest anion we have to select. Actually, you see the smallest anion is a fluoride ion, because and the biggest is hydride ion. So now we see here the biggest is hydride ion is the biggest one. The exception in the size of hydride ion is because this is the only anion with electron proton ratio is equal to 2. So that ratio is very highest for among these all four anions given. So the correct option is hydride ion, that is option C is a correct answer. So thank you. Then thank you friends. We will meet in the next video presentation. Please kindly subscribe my channel to have access on more videos on chemistry lectures. Thank you.